Hello, hello, hello. This is Coach Ikram, and welcome to this video on calorimetry. When we're talking about calorimetry, we need to start by talking about energy units, and we're going to discuss two of them, calories and joules. A calorie is the quantity of heat that is needed to raise the temperature of 1 gram of water 1 degree Celsius. It's a little bit different than a food calorie. A food calorie is used in nutrition. We capitalize it to differentiate it. And a food calorie is going to be the equivalent of 1,000 calories or 1 kilocal. And 1 calorie is going to be equal to 4.184 joules of energy. And that number is going to be significant. It's going to end up being the specific heat capacity of water. So the heat capacity is the amount of heat that's needed to raise the temperature of an object 1 degree Celsius. It's always going to depend on mass and composition. So for example, it's going to take more heat to increase the temperature of a large pot of water than it would a small pot of water. And it's going to take more heat to raise the temperature of water than it would, say, metal. So the specific heat capacity is the amount of energy it takes to raise the temperature of 1 gram of a substance 1 degrees at a constant pressure. And we're going to calculate it using this equation right here. The units for specific heat capacity, or CP as you'll see it often notated, are calories over grams degrees Celsius or joules over grams degrees Celsius. Water is going to have a very high specific heat capacity when compared to other substances. And you're going to be given these values or a table of these values if you need it. When we're calculating the heat that's required to change a substance temperature, we're going to use the following equation. Q equals MC change in T, or Q equals MCAT. Your Q value is going to be the heat that is either absorbed or released, and this is either going to be in joules or in calories. It's important to note that if your heat is absorbed, your Q value is going to be positive, and if your heat is released, your Q value is going to be negative. Your M is your mass in grams. Your CP is your specific heat. It's going to be in joules over grams degrees Celsius or calories over grams degrees Celsius. And your change in temperature is going to be delta T, and that's going to be in degrees Celsius. And note that delta T is going to be equal to your T final minus your T initial. So the temperature you finished with, subtract the temperature you started with. So let's practice this problem right here. So it says how much heat is absorbed by 500 grams of water, which has a specific heat capacity of 4.184, as its temperature is increased from 14 degrees Celsius to 75 degrees Celsius. So I'm going to start by listing out my givens and what I have. So I don't know the Q value. My mass is going to be 500 grams. My C value, as notated, is 4.184. And my change in temperature is going to be T final minus T initial. So in this case, if the temperature was increased from 14 to 75, it's going to be 75.0 minus 14. And I'm going to get 61.0 degrees Celsius. And it's important to note when I'm doing that, I follow the significant figures rules for addition and subtraction for that little piece of math. So now I'm going to go ahead and plug it into my Q equals MCAT equation here. So I don't know my Q value. 500, 4.184, and 61.0. And if you got the unit correct for your C value or CP value, you will note that all the units are going to end up canceling out. Grams will cancel out with grams, degrees Celsius will cancel out with degrees Celsius, and we're going to be left with joules. So I'm going to go ahead and multiply across, and I get Q is a positive 127, 612 joules of energy. That's a positive number, so heat is absorbed, which should make sense for this problem. I need 3 significant digits in my answer, so Q is going to end up being a value of 128 joules of energy. Practice another problem here. This is number 2. They have 5750 joules of energy is added to a 455 gram piece of glass at 24.0 degrees Celsius. What is the final temperature of the glass if the specific heat for glass is 0 0.840 joules over gram degrees Celsius. So again, I'm going to go ahead and write out what I have here. So I've got Q is 5750, and that is a positive value because it's being added. My M is going to be 455 grams. My CP value, my specific heat for glass, is 0.840. And my change in temperature, I don't know the overall change in temperature. I do know my initial, so it's going to be T final minus T initial, which was 24.0 degrees. So I'm going to go ahead and plug it all in. So I've got Q equals MCAT. My Q value is positive 5750. My mass is 455. My C is 0.840. And my change in T is going to be TF minus 24.0. So then I'm going to multiply across. I'm going to kind of move my work down here so you can see it. I'm going to have 5750 equals 382.2 times TF minus 24.0. I'm going to do distribution here. I'm going to end up with 5750 equals 382.2 TF minus 9172.8. Go ahead and mathematically solve for my TF variable, and I got T final is equal to 39.0 degrees Celsius. Another way to solve for this would be to solve for change in T as its own entity. Just plug in a change in T up here in the equation, and then later go back and use your change in T value and calculate TF. So you can do it either way. So calorimetry is the accurate and precise measurement of heat change for a chemical process. Calorimetry is based on the following understanding. If you have a system and its surroundings and heat is lost by the system, that's going to be equivalent to the heat that is gained by the surroundings. So the heat lost by the system then is going to be negative, and the heat gained by the calorimeter or the surroundings is going to be positive. And if my Q equals Q, that means that I can set my MCAT of the Q lost equal to the MCAT of the Q gained. The only thing is that the MCAT of the Q lost has to be a negative number. So you're going to have to put a negative sign in front of that when you're solving these problems. In order for this process to be accurate and precise, you would carry it out in a calorimeter. And we're going to talk about two of those. The first type of calorimeter that you could have is a constant volume or bomb calorimetry. This allows your reaction to take place inside of a closed container, which is going to be surrounded by water, and you're going to measure the temperature change of the water. The bomb will absorb some of the energy, so the heat capacity also has to be considered when you do your calculations. Another way of doing these accurately is doing it in what we call coffee cup calorimetry. And this allows your reaction to take place inside of an insulated container that's not sealed. You're still going to measure the temperature of the water, but the cups are open to the surroundings, so heat can be lost in any gases that are going to escape the cups. And note that these are both just a method in order to do your calorimetry problems accurately and measure your heat that is lost by your system. So if I was going to do a practice problem for this, this is what it would look like. It says we've got a 25-gram sample of metal at 75 degrees Celsius, and it's placed in a calorimeter that contains 45.0 grams of water at 23 degrees Celsius. The temperature stops changing at 29.4 degrees Celsius. What is the specific heat of the metal? We're going to assume that our device in this case doesn't absorb any heat. So my system is my metal, and my surroundings is my water. So when I'm going to go ahead and solve this out, I want a Q equals MCAT for both equations, and I'm going to set them equal to each other. So my MCAT for my metal will equal my MCAT for my water. And the MCAT for the metal, since the metal is starting at 75 degrees and the water is starting at 23, that means the metal is going to be losing heat. So that's going to be a negative on that side of the equation, and it's vital that you remember that negative sign. So my mass for my metal is going to be 25.0 grams, so negative 25.0 grams. My specific heat capacity for the metal We don't know. We're solving for that. My change in T, in this case, is T final minus T initial. It says the temperature stopped changing at 29.4 degrees Celsius. When you're doing calorimetry problems, the T final is going to be the same for both your system and your surroundings, because eventually, if it's got two different temperatures, eventually the heat is going to transfer and they're going to come to an equilibrium temperature. So in this case, 29.4 degrees Celsius will be used as my final temperature for both sides. If I was doing a problem where I was calculating T final, that value would be the same. I'd calculate it for one variable because it's the same on both sides. So on the left-hand side, it's going to be 29.4 minus 75.0. And that ends up getting me negative 45.6 as my change in temperature for my metal. And that is negative, and that's okay. The math is actually going to work out because your overall side of this equation is also negative. So this is negative 45.6. On my water side, my mass of my water is 45.0. My C value for water is 4.184. And my change in temperature is going to be 29.4 minus 23.0, which ends up being 6. So I'm going to go ahead and multiply across. I've got now on this side a positive. Divide out, solve for C, and I got C to be 1.057. I need 3 significant figures in my answer, and so I'm going to end up with CP for my metal. It's going to be equal to 1.06 joules over grams degrees Celsius. And that's all we've got in this video. Make sure you rewatch as needed, take notes, and come to class with questions. Okay?